Welcome back, dears. In 6.4, we have got line symmetry in polygons. We all know that in an isosceles triangle, we have got two congruent sides, two sides that have got the same measure. And we also know that there's a vertex and a base for every triangle. Okay, now we have something else is called axis of symmetry. What is axis of symmetry? Whenever I have got an isosceles triangle, the segment that joining the vertex, okay, the segment that we have joining the vertex of it here, this part, okay, to the midpoint of the base is an axis of symmetry of the triangle. By another word, I can say that anything that can cut a shape or an object into halves, okay, it will be called line of symmetry or axis of symmetry. So in an isosceles triangle, okay, the angles opposite to the congruent sides will be also congruent. What does that mean? So I have this side and this one, they're congruent to each other. So for sure this is an isosceles triangle. This angle here that's opposite to the congruent side is 36. Now I'm asking what will angle IKJ be? So I take a look at it, it's opposite to the congruent side. Also, it will be 36 because they will be congruent to each other. Then, Miss, I have got a question. How do you find measure of angle I? Is also measure of angle I 36? Of course, no. Why is that? This triangle is an isosceles triangle. 36 and 36, if you add them up, you'll get 72. So that means we need more numbers. What do? The sum of a triangle is 180. So when we add those two, I get 72. I gotta subtract it from 180. And when we do this, I get 108. So the measure of angle I will be how much? 108. Now on page 246, we have a very important note here. It's talking about line of symmetry, and it says that in any regular polygon, you can find line symmetry. How? So that's a pentagon. If I count the sides, 1, 2, 3, 4, 5, I will see that it has 5 sides. And if they asked you how many axes of symmetry it has, you will directly count the sides and say it's a regular polygon. So pentagon has 5 axes of symmetry. How? First step, when I draw a line from A to DC, and from B to ED, and C to EA, and D to AB, and E to BC, I will see that, okay, I will get 10 triangles. How is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 triangles, and how many axes of symmetry? 5 axes of symmetry. How did we get this? You can first start with the vertices, okay, make the vertices bold, and then from the vertices go to the opposite part of this side that you have got. And then you continue like this until you get 10 triangles. Your answer will be correct at that point. And be careful, dear students, 5 axes of symmetry. What about a rectangle? A rectangle is a shape that can only be having only 2 axes of symmetry. Now, some students will draw like this, 1 and 2. Be careful, this is wrong. Because when you fold it, they will not overlap each other. So in a rectangle, I have 2 lines of symmetry. One like this, when I cut it, okay, it will make a half. And one the other side, it will also make it half. Also, we've got a square. For a square, it has 4 lines of symmetry, 4 lines of symmetry, axis of symmetry, because a square has all sides that are congruent to each other. So like this, I'll get 8 triangles and 4 lines of symmetry. And hexagon, a regular hexagon, 6 sides of 6 axes of symmetry. Be careful, dear students, whenever you've got a regular polygon, you only count the sides and you directly write the number. So here, when I count the sides, I'll get 5, and it's a regular one. So the answer is 5 axes of symmetry.